So the one group might have been way over here on the scale, the other group over here on the scale, and when we standardize them, it brings them to the center.
Quadrant 1.
Yeah, and it's always usually between 3 standard deviation from the center. So 1 standard deviation is 1 unit.
That's why
2 standard deviation is 2 units, and 3 standard deviation is 3 units away.
And this would be Z, right?
Now,
because X, Y, right? And then Z would be the slope that you get, right?
So
because when I look at the numbers, right, going on in your homework and everything that you're teaching us, I'm trying to visualize what I'm looking at as I solve the problem and I'm writing it out. My mind is just constantly grabbing at me to try to think of what it looks like on a slope, like on a graph like this, basically, what it would look like. So I'm always like, what is Z?
For me, who again is like the algebraist, kind of pure math person, when you say X, Y, or Z, I'm thinking of 3 planes. So what we're looking at on the screen is a 2-dimensional, right, environment, where this would be like you take that 2-dimensional plane, X and Z, and you give it a third or X and Y, rather,
X and Y,
you give it a third dimension so that it comes out into space, and that's where Z comes from. So now you're in a 3-dimensional, like we live in a 3-dimensional world. This table is 3-dimensional, right? It has length, it has width, but it also has a height, right? So a point out in this picture that I've got here is really like out in space.
Okay. Length, width, and a height. Okay. Now here's where I need you. How do you go ahead and take the like what the mean and median mode would be, or the length, width, and height, and how do you what formula is that called to bifaction that into basically time, right?
Right. I think
so. If you have like 100, right? Would that be like to put it into, because you're basically, if you're making it time, you're just adding a I'm thinking of too many words right here. Not a comma, but what is it? What are these? Ratio, right? Yeah, to change it from a number into a ratio. That would be like digitized time, right? Is that the same thing? Is that the same function?
You know what? I'm actually unsure how to answer, but what I'm hearing is like length, width, and height, and then time is like this 4th dimension here. So in now 3 dimensions we can visualize. Because like, okay, is this point on the wallpaper or is it out in space, right? Your eye,
like holographics,
your mind
like
can imagine it out in the space, like if this is right, the X and Y, the point might be here living, like there's space behind it.
Okay.
So that's,
I see what you're saying.
That's the 3-dimensional space, which we can visualize because we live there. Now, when you get up to 4 dimensions,
that's when it starts to get a little bit tricky.
That for, I think for most people is actually like impossible to visualize.
But you can actually write it out in a mathematical formula, right? Like it can be calculated. What's that called? What that formula called?
Oh, I don't know. know. I think the word is like a relation, perhaps a function, right? I'm not sure. Relation is like a function, but it's not quite a function yet. So like
I'm with you on that, because ratio, relation, the words kind of have roots in each other.
And then maybe there's like a bijection might be a word, like a pathway from one to the other or backwards. The formula, quote unquote, for that, I have no idea. I'm now lost in the woods. But what I will say is that there is like theoretical spaces, right? Like, have you heard of string theory before?
Yeah, I've heard of string theory.
So I think that's like 12 dimensions or something. Like, so, there's higher order dimensions that I can't conceptualize because I don't live that in my everyday experience. And I don't do those types of math. Like, my focus is
that would be like augmented reality or like virtual reality holographics and stuff that they do. Like, that's what that's used for.
Somebody in a physics or astronomy department might be a little more interesting to speak to. Like, I can kind of name some of the function types,
things that you've come across and stuff like that.
But when it really gets down to the nitty gritty, like, what's the formula for that? Girl, I got C's in physics. I don't know. And so same with astronomy. I never took an astronomy course. I just know what I know from listening to Neil deGrasse.
I'm familiar with him too.
So I'm an intermediate Star Talk listener. That's about where the scope of my knowledge ends.
All right. Well, that's pretty much about it. I was just trying to figure out the intervals in the sound waves, how that affects our atmosphere. Because, you know, they say as above, so below. Mm-hmm. So I was thinking, like, in theory, like, ripples create disruptions in Wi-Fi signals and stuff like that, right? Mm-hmm. So, like, if something's running across a ripple, it trips over something, right? Mm-hmm. So usually, well, like, when your phone has trouble or something like that, that's because the weather or something like that, right?
Yeah, there's a disruption
in what's going on
in the pathway.
Yeah, you know what I'm saying? Mm-hmm. So I was thinking, like, maybe the meteors that come from, or the space debris that comes from space, mm-hmm. has an effect in our atmosphere somehow. Mm-hmm. And I was trying to calculate that. Interestingly enough, 369, I'm sure you're familiar with Nikola Tesla, right? And the number's 369. So when you use binary, right? 1, 2, 3, 4, 5, 6, 7, all those numbers up there, right? Those numbers actually infinitely repeat themselves when you add them to each other. However, every time they're repeated, they lack the numbers 369 in every.
Oh, interesting. Yeah, I haven't explored. I know that there's similar sort of fun pathology. How is this happening?
Yeah.
So I'm not familiar with that one, but that's cool.
So that's a phenomenon, right? Mm-hmm. And I noticed on the phone that 369 was the same time like the Wi-Fi would mess up on my phone. 3 a.m., 6 p.m. and I think it was like almost 12 or something like that. So I think it's in threes. Uh-huh. Yeah, so I don't know. These numbers are just messing with me because I'm like, there has to be a connection, but I have to put it in a formula. I'm trying to get this patented. You know what I'm saying?
That's interesting too. So there's also like the danger of what is it, like epiphany and epiphany?
Epiphany and epiphany. No, so, I heard epiphany, but not epiphany. Yeah.
So I like both of them because they're both valuable. One I think is more rooted in like schizophrenia, but I believe that
I understand.
But I believe that everybody has like an epiphany moment where you go, these two things are connected, right? And so you don't have to have schizophrenia to have that phenomena happen. Like I've had somebody go, for whatever reason, the number